Hey guys, so today we are going to be talking about section 6.3 exponential properties, and today is the 19th. The first property we are going to learn is the multiplication property. Okay, before we dive into the multiplication property, I want us to do some examples to help you understand it. So, example A, if I gave you 3 to the 4th times 3 squared, what would this look like in expanded form? So hopefully you're thinking, okay, well 3 to the 4th is the same as 3 times 3 times 3 times 3. So that's 3 to the 4th. 3 squared is the same as 3 times 3. So now, how many 3's do we have total? 1, 2, 3, 4, 5, 6. So we could rewrite this as 3 to the 6th. Continuing this, let's do it here, B. What about x cubed times x to the 5th? If I wanted to expand this, it's the same as x times 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 x. 1, 2, 3, 4, 5, yeah. So then, how many x's do we have total? We've got 8, so I can rewrite this as x to the 8th. Alright, let's do 2 more. C. One plus 0.05 squared times 1 plus 0.05 to the 4th. Let's just do one more. So, expanding this, kind of annoying. 1 plus 0.05 times 1 plus 0.05 times 1 plus 0.05. Keep going. Okay, so I've got the 4, 1, 2, 3, 4, and I've got the 2. So I've got total 1 plus 0.05 to the 6th power. Alright, if we wanted to generalize this, hopefully we can agree, we reach the conclusion that we can add the original exponents. So if I have b to the m times b to the n, that is the same as b to the m plus n. Okay, so this is the generalized formula of the multiplication property. Okay. And if we go back to the examples, it makes sense, right? So going back up, okay, what's 4 plus 2? 6. So, works here. 3 to the 4th times 3 to the 2nd. 4 plus 2 is 6. X to the 3rd times x to the 5th. 3 plus 5 is 8. Notice that the base of your exponent does have to be the same. So as long as we have b to the m and b to the n, it's b to the m plus n. That's really important. Okay, so that's the multiplication property. The next property is called the power property. Let's use purple. Okay, and it's a similar idea, so let's learn via example. Example A, if I gave you x squared cubed. Well, this cubed right here is telling us to rewrite this 3 times. So it's the same as x squared times x squared times x squared. The x squared is the same as x times x times x times x times x times x. So how many x's do we have total? 6. Another example could be like x y to the 4th z cubed, we'll keep it small for now, all squared. So again, this 2 is telling us to write this whole thing twice. Oops, wrong color. So that would be x y to the 4th z cubed times x y to the 4th z cubed. If we expand what's in these parentheses, we have x times y times y times y times y times z times z times z times x times y times y times y times y, 1, 2, 3, 4, times z times z times z. So we've got total x squared y to the 8th z to the 6th. Hopefully you're noticing a pattern that we can multiply. We have to be very, very clear that this is not distributing. So first, let's generalize it. If I have b to the m to the n power, that is the same as b to the m times n. Similarly, if I have different bases, if I have a times b to the power of n, it's the same as a to the n, b to the n. Remember, this is not distributing. This is the power property. You don't have to memorize that it's called the power property, but you need to not call it distributing. And we've got time, so, well, I'll show you tomorrow. Okay, so doing some examples with these. Example 1. Four to the 5th squared. So if we use the power property, we can multiply, so 5 times 2. This is the same as 4 to the 10th. So what's 4 to the 10th? And you can use your calculators. You should get 1,048,576. Okay. Oops, sorry. Example 2. X squared y to the 5th all to the 4th. So this is another power to a power property. We're going to take our 2 and multiply it by 4. So this will be x to the 8th and then y to the 20th. Okay. Example 3. 6 times x to the 7th all squared. So the thing about this one is you have to remember that 6 does have an exponent technically of 1. So if I'm going to solve this, it's going to be 6 squared times x to the 14th. And we do need to simplify, so 6 squared is the same as 36. So we've got 36 times x to the 14th power. Let's do a couple more, we'll make them a little bit more difficult. So example 4. 3x to the 4th, y, z to the 7th, all of that squared, times 4x cubed. Oh, here we'll do 4x all to the 3rd. So we need to do this just like order of operations. We would have to do what's in the parentheses first. Nothing can be simplified, so we have to apply our exponents. So we're going to do 3 squared, 4 times 2, x to the 8th. Y is technically to the 1st, so this will be y to the 2nd. 7 times 2. Then I'd do it for this one. So we've got 4 cubed and x cubed. At this point we can simplify. So 3 squared is the same as 9. 4 cubed is the same as 64. That's one you guys probably should know without a calculator. And then 9 times 64 is 576. Now we can use the multiplication property. So we've got x to the 8th and x cubed. So that can be added, 8 plus 3, 11. And then we'll just bring down everything else. So we have y squared and z to the 14th. That's our final answer. Alright, so I'd like you guys to try to do a problem like this, example 5, with your group mates. So I'm going to give you a challenging one. 4x squared y to the 5th all cubed times 7x y to the 6th all squared times 6y to the 8th. So pause the video and try to do this with your group mates. Okay, so the first step is to use your power property. So 4 cubed, 64, x squared to the 3rd is x to the 6th, y to the 5th to the 3rd is 15. Then 7 squared is 49, x squared is x squared, y to the 6th squared is y to the 12th, and then we just bring down our next one. The next thing you do is just multiply everything. So 64 times 49 times 6 is 18,816. X to the 6th, x squared, no x, so 6 plus 2 is 8. Y to the 15th, y squared, y to the 8th. So that's what, 35. And that's our final answer. So your homework tonight is a worksheet where you're practicing the properties of exponents. So please use the rest of the period. I will be checking this tomorrow, so try to get it done and correct. Have a good afternoon, everyone.